Hello Pre-Calc BC, we are moving on to Chapter 3, Polynomial and Rational Functions. This is a really fun chapter. I like it a lot and I hope you do too. So let's get started on our Day 1 notes. Alright, so we have some information up at the top for you about quadratic functions and models, which is our main discussion today. So the two main forms that we care about for quadratics are standard form. This is the form that you would factor or use quadratic formula from, and then vertex form. This is the form that we would end up with once we've completed the square. Now, when you're in standard form, you can find a vertex using this method, negative b over 2a. That finds the x-coordinate of your vertex, and then you're just going to plug that back in to the function to find the y-coordinate. To be perfectly honest, I don't usually use this method, but you're welcome to if you'd like. Vertex form, we know we can find the vertex using h comma k, and this has to do with the transformations that we were talking about in our last unit. Okay, so we'll still see those transformations occurring over the next couple chapters. To find our x-intercept, we can find that by factoring, graphing, or quadratic formula, and really just remember an x-intercept is where y equals 0. Okay, and our y-intercept is just f of 0, which is where x equals 0. And we were doing that in our last chapter as well. All right. So this first problem, we are going to graph the quadratic equation f of x equals blah, 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 by converting it to vertex form and then listing the transformation steps. We're going to identify the vertex, the intercepts, the axis of symmetry, domain, and range. Okay, and axis of symmetry is just the vertical line that cuts our parabola right in half. It will always go through our vertex. So we'll get to that in a minute. Okay, so let's go ahead and start by completing the square. And to do that, we will pull out our -2, but only from those first two terms. Make sure you watch your sign here. And then we're going to leave ourselves a space. Put my -37 out here. Leave ourselves a space. So again, what you're going to do is take your b value, which is -8. We're going to divide it by 2 and then square it. So divide by 2, -4, square it, 16. But this isn't really a 16, it's really a -32. So we're going to have to counteract that by adding 32 on this side. Okay, and then we should be able to factor. This will become a perfect square trinomial, or it is a perfect square trinomial, I should say. Multiplies to 16, adds to -8. That becomes x minus 4 quantity squared. And -37 plus 32 is a -5. All right, so that right there is our vertex form. And now let's go through the list of things we need to do. Identify the vertex. Okay, well, the vertex is going to be 4, -5. Just like with absolute value equations, your x-coordinate switches and your y-coordinate excuse me, stays the same. This also has to do with our transformations. This x minus 4 means we're moving to the right 4, which is why our vertex is a +4. Okay, so there's our vertex. Now let's go ahead and list the transformation steps. I guess I was supposed to do that first. Oh well. So your original function would just be x squared. That's our parent function. And then we'll just go down the lines of what each transformation would be. So remember our PEMDAS of graph transformation. You'll start with your horizontal shift, which is this guy. So that's going to be the f of x equals x minus 4 squared. And I do want you to put that's right 4. Okay, so then we do not have any sort of horizontal stretch compress. That would be right there. So we're going to jump to this guy, -2, and that is going to look like this. That will be a vertical stretch by a factor of 2, but it's also reflecting over the x-axis because of the negative. So that's too much for me to want to write. So I am just going to simplify it and say multiply y by your -2. Okay, the stretch is multiplying by 2 and the reflect is multiplying by -1. So -2, there we go. And then our final graph transformation is that -5. So now we'll write the whole thing, and we know that that's down 5. Okay, so now that we've just done this, we might as well graph this, right? So your parent function, I'm just going to go ahead. I'm going to just do the first 3 dots. Oh, and this is not the best graph ever since this should be a 2, 4. Oh well. It's close enough. Okay, so let's use those graph transformations to now graph this. And again, the benefit for me of converting to vertex form is that you can graph this by hand, which is something that you may have to do without a calculator. All right, like this I think is an acceptable non-calculator problem, whereas if you just leave it in standard form, graphing that is going to be more difficult. So, okay, I'm going right 4. So I'm going to start at the vertex right 4, 1, 2, 3, 4. I'm multiplying my y by -2, so that's just going to stay there. And then I'm going to go down 5. 1, 2, 3, 4, 5. Okay, there's my vertex. Next, I'm going to do 1, 1, right 4, 1, 2, 3, 4. Multiply my y by -2. So 1 times -2 is -2. And then I'm going down 5. 1, 2, 3, 4, 5. And then you're going to do the same thing with this other point. What some of you may realize is, hey, it's a parabola, this graph is symmetrical, so the other point should be here, and then you can just graph it. Okay, and if you type that into your calculator, it should look just like that. Intercepts. All right, what else do we need? Well, the nice thing about graphing this is seeing that we do not have any x-intercepts, right? Because it's been reflected over the x-axis, it's opening downward. So we're just going to say no x-intercepts. Now I know based on my picture, it doesn't look like I have a y-intercept, but I will eventually. Your y-intercept, remember, is just f of 0. So when we plug a 0 in for x, we'll see our y-intercept is at 0, -37. So doesn't fit on my graph quite exactly. Axis of symmetry, that's going to be the vertical line that cuts through this parabola. Make sure you put in x equals because it is a line, and it would be the equation x equals 4. All right, and finally, domain and range. Domain, we know for a parabola, our domain is always all real numbers because any value of x is acceptable. And for my range, my highest value is up here at -5, and then it's going down into infinity. So I'm going to say this is from -infinity up to -5. I am going to use a bracket for that -5 because we are including that value. And then make sure when you use interval notation that you always put the smaller number first. So that's why the -infinity is coming before the -5. Okay, so I think we found everything there. If this did have x-intercepts when you graphed it, what you would need to do would be to either factor your standard form if you wanted to, or if you couldn't factor it, you could do quadratic formula, okay? Or what you could also do is you could go ahead and take your vertex form here, plug a 0 in for y, and then you could actually solve it. All right, so like if I do that for this problem, I would add, like, I don't really want to erase all this, but hopefully you have it written down. Okay, I'm going to erase it, and you can either choose to write this down or not. But like, let's say I didn't actually graph my parabola. Like here I can clearly see there are no x-intercepts. But if you didn't see that graph, you could just plug in a 0 over here, add your 5 over, and then divide by your -2. And then if you look, what's going to happen here is you're forced to square root both sides and square root a negative, which we cannot do, which tells you that you don't have any x-intercepts. Okay. All right, so there's that. Let's move right along. Determine the quadratic function whose graph is given. Well, what you should notice here is that you do have the vertex. So writing a quadratic function in vertex form would be great. Our problem is that we don't have our a value, so that's something that we do want to find. I'm going to write vertex form first. And don't forget about this squared. This is something people just lose. Since this is a parabola, that squared is obviously pretty important. Okay, so I'm going to plug in the information I have, and I always prefer to do this in 2 steps because otherwise I find that I mess up. If you don't, congratulations for you, but I tend to mess it up. So first I'm going to plug in my vertex. So I'll have x, it would be -2 because I'm using my opposite for your x coordinate, and then +1. And then I'm going to take this second point, 4, 5, and my 4 is going to be my x, and my 5 is going to be my y. So now I'll just plug those values in as well. And then I should be able to evaluate this to solve for a. So that's 4 minus 2 is 2 squared, so that's a 4a plus 1. And then we'll just go ahead and solve this. And you should get that a is 1. All right, so then we'll just go ahead and take this and we'll plug it back into our original equation that had the vertex plugged in. That's another reason that I like to plug the vertex in separately, because then you can just go right back up to that. If you want to put a 1 there, you can, and there you go. That's your equation. Ta-da! All right, next. A suspension bridge with weight uniformly distributed along its length has twin towers that extend 75 meters above the road surface and are 400 meters apart. The cables are parabolic, or a parabola, in shape and are suspended from the tops of the towers. The cables touch the road surface at the center of the bridge. Find the height of the cables at a point 100 meters from the center. So here is a general picture of what we're looking at if you're not sure what a suspension bridge looks like. The difference between what we have happening here is it says that the cables touch the road surface at the center, whereas here it does not appear that they do. So I am going to draw my own bridge. It's going to be awesome. Oh boy, it's already not awesome. Wow. This is incredible. Oh, best bridge ever. Okay, great. So it says that we have twin towers. So there are my twin towers that extend 75 meters above the road surface. So what you should take from that information is that your height is 75 meters. They are 400 meters apart. Okay. The cables are parabolic in shape. Okay, here's my cable. The cables touch the road surface at the center of the bridge. All right, so here are some options for you. One thing that you want to do is kind of identify where the vertex is. What I think is helpful most of the time is to just say your vertex is at 0, 0 in this situation. And if that were the case, then over here would be the point 200, 0, right? Because if it's 400 all the way across and we're right in the center, it would be 200 on each side. That means that this point up here would be what? Okay, it should be 200, 75. And again, I know my drawing is not the most accurate, okay, so just kind of go with it. So let's examine what we're actually trying to find here. It says find the height of the cables at a point 100 meters from the center. So 100 meters from the center, that would be like here. And they're looking for the height. So we are looking for a y coordinate. Okay, now you could also, work with this point over here. This would be a negative 275 if you'd like, but I think most people would just prefer to work with the positive. Okay, all right, so what are we going to do for this? Well, one thing that helps is to start with a vertex form. Okay, so this is actually similar to our last problem. I'm going to plug in my vertex, which is just 0, 0. So this is just x squared, right? Because h and k are both 0. And now I have another point. I have this 275 or the negative 275, and I can plug those in as my x and my y. Okay, and then I can go ahead and solve for what a would be. So I'm just going to do, find a good place to put this. What was it? 75 divided by 200 squared. And I'm going to math frac this. So 3 over 1600 is what I'm getting for a. All right, so now let's write our actual equation. It's just going back up here. Y is equal to 3 over 1600 x squared. Okay, so let's look at again what the question is. We want to find the height of the cables at a point 100 meters from the center. So that 100, what is that representing? Okay, it should be your x. So what we're just going to do is plug our 100 in for x, and then we should be able to evaluate to find our y, or our height. So 3 over 1600 times 100 squared, and we get 75/4, which is just 18.75. And that is meters, I believe. Okay, now if you decided to plug in negative 100, because that would be 100 feet or 100 meters in the other direction, if you look, you're squaring it, so you're going to end up with the exact same answer. So right up here at this point, we would be 18.75 meters tall. Fun! Okay, one more. A side of a house is in the shape of a rectangle surmounted by an equilateral triangle. If the perimeter of the entire house, or entire side of the house, is 55, so that means this, okay? What dimensions will maximize the area of the side of the house? Okay, so this is one of our modeling problems again, and we're going to see more of these this chapter as well. Generally, you want to start by picking a variable. How about x? And I'm going to put x here. This is an equilateral triangle. So while those are both x, and this is x, it also means that base of our rectangle is x. Now remember, the base of your triangle is not being included in our perimeter. Okay, and then I'm just going to call these guys y. Okay, so a couple of different things you need to consider for this problem. You need to be able to write an equation that represents perimeter, but you also need to be able to find the area of both the triangle and the rectangle. Okay, so let's write that formula first. The area of this whole house is going to be the area of the rectangle, which would be xy, right? Base times height, plus the area of the equilateral triangle. Now, there is a very helpful formula to know for the area of the equilateral triangle. And what that is side squared root 3 over 4. It has to do with the fact that an equilateral triangle has 60-degree angles. So when you drop your altitude, you would get a 30, 60, 90 triangle, and then you would use 30, 60, 90 triangles to do 1/2 base times height, blah, 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 blah. Long story short, this formula is side squared root 3 over 4. It will work for every single equilateral triangle. Your side is x. So x squared root 3 over 4. That's our area formula that we are going to be maximizing. Now, the issue right now is that we have both x's and y's in it. Since there are already two x's, I'm going to suggest we get rid of y. Okay, it seems like it'll be easier to type into our calculator. That's where your perimeter formula comes in, because your perimeter allows you to show a relationship between x and y. Okay? So perimeter is 55. How else do we represent that? It's 3 x's and 2 y's, right? So I'm going to say 3x plus 2y equals 55. And now, since I want to replace the y, what I'm going to do is solve for y in this equation. Okay, so I'll just subtract my 3x over, and then I'll divide by 2. and you can write that any way you'd like. But the point is that this can now go in place of that. Okay. All right, so I have x times negative 3 halves x plus 55 over 2 plus x squared root 3 over 4. Now, you can simplify this as much or as little as you'd like, because here's the thing. Your calculator is going to do all the work for you anyways, right? So if you don't want to simplify it and you just want to type that whole thing in, that's totally fine. Okay, so let's go to our y equals x parentheses negative 3 halves, which is negative 1.5, x plus, that should be what, 27.5? Okay, plus, okay, I don't know if your teacher showed you this last year, but there's this little thing called alpha y equals enter that makes your life completely better. It makes a fraction bar on your y equals. You go alpha y equals enter. And what that allows you to do is go ahead and type in a fraction more easily. This is going to be really helpful in this chapter. Okay, so then I'm going to graph. And well, clearly my window is not what it should be. So let's go check out my table. At 10, it looks like I'm up at 168. Okay, so 400, that seems a little much. So let's just go down to, let's start with 100. And then at 10, I was up at 168. So let's say, I don't know, let's say 400. Let's see what happens. Okay, looks pretty good. I can zoom in a little bit if I'd like. But we're looking for the maximum area. So I'll just go ahead and do second trace max. And where's my cursor? Where are you? Oh, I think I'm like, oh my gosh. It's gonna take, oh, there we go. There we go. Okay. All right, so left bound, right bound, guess. Okay, so I'm getting a 12.887, comma 177.1923, or sorry, 193. So let me just write that down. Okay, I have it on my paper. 12.887, comma 177.193. Okay, hopefully that's right. Now, if we come over here, let's make sure we understand what this point means. The 12.887, that's your x, okay? Because that's the variable that we are using in regards to this function, right? It's in terms of x. Now, the 177.193, yes, that is your y coordinate of the maximum, but it's not talking about this y. Look at your equation. It was a equals. So this y coordinate is your area, okay? That's your max area. Now, what you're being asked for is the dimensions. So what we want is both this x and this y. We have the x, okay? X is 12.887, and then what unit did I give you? Feet. Okay, the max area is this, the 177, but that's not what you're being asked for. You're being asked for what y is. So here's something cool your calculator does. Every time you find a min or a max or an intersection point, whatever you found saves as x automatically. So check this out. If I go back to my home screen and I click x up here, it's saved, like the whole thing, the exact answer, which is great because now what you're going to do is you're just going to go up to your equation right here that relates x and y, and we're going to plug that whole x value back in. Okay, you do want to use the whole value from your calculator. So that's negative 3 halves x plus, I think it was 55 halves. Oh yeah, it's right there. And we get 8.169. Okay, so it should be 8.170 feet. Okay, and those are your dimensions, and you absolutely have to have your units. Okay? All right, well, hopefully this was super exciting for you, and let me know if you need anything. Have a great day.